Hi, welcome everybody. Here's our Project Euler for question 2. The statement is this. Each new term in Fibonacci sequence is generated by adding previous two terms by starting with 1 and 2. The first 10 terms will be 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and so on. These are the 10 terms first in the Fibonacci sequence. So by considering the terms in Fibonacci sequence whose value do not exceed 4 million, find the sum of the even value terms. Okay, what is Fibonacci sequence? So Fibonacci sequence is something like this. Fn equals to Fn minus 1 plus Fn minus 2. So when n equals to 1, F1 equals to 0 plus 1 equals to 1, n equals to 2, F2 equals to 1 plus 1 equals to 2, n equals to 3, F3 equals to F2 plus F1, which is 3, and so on. So the value will keep on increasing until the question which states that the number doesn't exceed 4 million. So we will sum the numbers up. Okay. Here's a solution. To make the operation faster, we are actually storing the value of each Fibonacci number into an array. For F3, if we want to get F2, we need to travel through F2, and which F2 will get the value from F1. It's done in a recursion, but to make the things faster, we can count them up from 1 to n. If we get the number of F2, then we will get the number of F3 by simply multiplying the number of F2 and F1. Sorry, sum. Okay. So this is solution. We will add through all the n values, n equals to 1, until the n Fibonacci terms becomes more than 4 millions. So this is the for loop. And if the Fibonacci number for n term is more than 4 million, then we break. Otherwise, we check whether it is even number or not. If it is even number, then we will add it to the total. And finally, we will print the total number, total sum of the numbers. Okay, for this part is a bit tricky. That involves a bit of dynamic programming. So dynamic programming is a technique that improves a lot of computational time, so that the program can be done faster. It's simply by saving the previous value and reuse them when we retrieve the next value. So that's what I explained earlier. We get f equals to 1, then we get f equals to 2, but for f2, we use a number from f1 and f0, and for n equals to 3, we use a number from f2 and f1, and n equals to 4, we use number from f3 and f2. So it is 5. Okay. So this is the solution.